So in the next several videos, we're going to walk through the proofs of the summation formulas that were given to you in your homework assignment. The first one we're going to look at is the easiest. It's this repeated sum of a constant. And so the claim was that if we have the sum from I equal 1 to n of a constant, so this is a number like 2 or 7 or the square root of 3 or pi, that we can get a shortcut formula by just multiplying the constant times the upper bound of summation, so c times n. And if you were looking at trying to prove this, really what you would do is you would take the sum from I equal 1 to n of c and recognize that you're just adding c to itself repeatedly, c plus c plus c plus dot 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 plus c. And when you get to an upper bound of n, when you've done it a certain number of times, you're going to stop. And what you need to then identify is how many times have you done it. Well, we know from a previous video that the number of terms that you get in a sequence is just equal to the upper bound plus 1 minus the lower bound. So in this case, you're just going to get n. In other words, if you take the sum from I equal 1 to n of c over and over again, you get c n times. So this is just a repeated addition, and we know from elementary school that we can represent a repeated addition if it's a natural number of times as just the number of times we repeated the addition, n times c, and that's where the formula comes from. Remember, the order of multiplication doesn't matter, so I can write n times c or c times n, and it means the same thing. So in this case, the formula just comes from the idea that you're repeatedly adding c to itself, whatever the constant is, n times.